This is the second video on chapter 41, arc length. And so here we're going to do another example. We're going to find the arc length of the curve y equals 3 cubed root of x squared minus 10 between 8 and 27. So x ranges from 8 to 27. So we'll calculate the derivative to start with, and then we will integrate the derivative squared plus 1 all under the square root. And we're integrating from 8 to 27. And at first this looks fairly intimidating, but we just look at it step by step. So the first thing we do is we get a common denominator and write this as one fraction. We notice that the square root of the cubed root of x squared is simply the cubed root of x. So we simplify this a little bit from this step to this step. Then we notice that the derivative of 4 plus the cubed root of x squared is, we take this derivative, so we can look at this as x to the 2/3 power. When you take the derivative, you have 2/3 x to the negative 1/3, and x to the negative 1/3 is equal to 1 divided by x cubed. And so this tells us that substitution is going to be a good method for integrating this function. So we set u equal to this expression, the 4 plus cubed root of x squared. That means the du is going to be 2/3 x to the negative 1/3, which we can write like this, 2 divided by 3 times cubed root of x. So this integral will apply substitution. We change our limits of integration. We have to change our limits from x limits to u limits. So when x is equal to 8, u is also equal to 8. So we changed 8 to 8. But when x is equal to 27, u is equal to 13. So we change 27 to 13. And then we have the integral of 3/2 square root of u du. This integral looks a lot easier to integrate than this one. So now we have something that is relatively simple to integrate. Remember, square root of u is u to the 1/2, so we simply reverse the power rule. And so now we have just the square root of u cubed. We evaluated at 13, we evaluated at 8, and we subtract.